I've spent the last 2 months going through Australian War Memorial Archives, Seabee construction reports, and declassified logistics manifests from both the 1st Australian Task Force and the U.S. Army's Construction Command in Vietnam. What started as a simple question about building materials turned into one of the most revealing stories I've ever found about how two Allied armies thought about war itself. The Australians shipped corrugated iron halfway across the Indian Ocean. The Americans shipped plywood halfway across the Pacific. Both armies looked at the other's choice and shook their heads. But within 18 months, one of those materials was rotting, warping, and being devoured from the inside out. And the other was standing exactly as it had on the day it was erected. The numbers I found in the maintenance logs still don't seem real. Nui Dat, Phuoc Tuy Province. August 1966. The heat comes first. That's what every veteran I spoke to told me. Before the mosquitoes, before the smell, before the mortars, the heat. By mid-morning at the 1st Australian Task Force base at Nui Dat, it was already pressing past 100 degrees Fahrenheit, and the air felt like breathing through a wet towel. A detachment of sappers from the 17th Construction Squadron, Royal Australian Engineers, were unloading sheets of corrugated galvanized iron from a flatbed truck. The sheets caught the sun and threw blinding silver light across the compound. A group of American advisors passing through the base watched with something between amusement and pity. One of them, a U.S. Army captain attached to 2nd Field Force headquarters at Binh, reportedly turned to his Australian counterpart and said, "You guys are putting up tin sheds? We've got Seabees building real structures down at Cam Ranh." The Australian engineer, a lieutenant whose name appears in the after-action reports as simply Lieutenant K.R., didn't argue the point. He just nodded and kept working. What that American captain didn't know, what almost nobody understood at the time, was that those sheets of corrugated iron would still be standing 6 years later when the Australians handed Nui Dat back. And the plywood structures the Americans were so proud of. I found maintenance reports that told a very different story. What I discovered in those documents changed everything I thought I knew about how wars are actually fought. To understand why the Americans looked at Australian base construction with such condescension, you have to understand the scale of what the United States was building in Vietnam. This wasn't a military deployment. It was an industrial migration. In November 1965, Secretary of Defense Robert McNamara met with General William Westmoreland in Saigon and promised $1 billion in construction funding. The plan called for 6 new deep-water seaports, 8 jet-capable airfields, and an entire network of supply bases stretching from the Mekong Delta to the DMZ. The Civilian Construction Consortium RMK-BRJ, the largest construction project in history at that point, was employing tens of thousands of workers and consuming 100,000 tons of shipping per month in construction materials alone. They were building a country within a country. And the primary structural material for the vast majority of these buildings, plywood, American softwood plywood, shipped across 12,000 miles of Pacific Ocean in enormous quantities. Plywood barracks, plywood mess halls, plywood command posts, latrines, recreation huts, and supply sheds. One former Seabee I found in the records described the construction program with obvious pride. "We could put up a 20 by 48 structure in a single day. Framing, sheathing, roof, done. You couldn't do that with anything else." He was right about the speed. A Seabee construction team with standardized plans and pre-cut lumber could erect a plywood building with astonishing efficiency. At Binh Post alone, the largest U.S. base in Vietnam, which grew to house 60,000 personnel, row after row of identical plywood structures stretched across the landscape like a prefabricated American suburb transplanted to the tropics. The logic was sound by American standards. The U.S. military had used plywood extensively in the Pacific during World War II. It was lightweight, easy to work with, and could be mass-produced in American mills and shipped in standardized dimensions. The entire U.S. military construction doctrine was built around it. As one Naval Facilities Engineering Command report I found put it, wood frame construction with plywood sheathing represents the most efficient use of shipping tonnage per square foot of enclosed space. When American officers visited the Australian base at Nui Dat and saw corrugated iron roofs over timber frames, structures that looked like they belonged on an outback cattle station rather than a military compound, they saw primitiveness. They saw an army that couldn't afford proper buildings. General Westmoreland himself, visiting one ATF in January 1967, was broadly critical of the Australian approach, reportedly labeling the task force as very inactive. Reading through these reports, I kept thinking, the Americans weren't just judging Australian construction. They were judging an entire philosophy of war, and they had it completely backwards. The Australians, for their part, said very little. They had learned something in Malaya that the Americans had not yet been taught by Vietnam. In the tropics, simplicity isn't a weakness, it's a weapon. The story of corrugated iron in Australia doesn't start in Vietnam. It starts in 1829, when a London engineer named Henry Robinson Palmer discovered that pressing thin iron sheets into ridges and grooves gave them remarkable structural properties, far stronger and more rigid without adding weight. By the mid-1800s, corrugated iron had arrived in Australia, and settlers quickly realized its value in the harshest inhabited landscape on Earth. During the gold rush, corrugated iron became the building material of the Australian frontier. A man could carry sheets of it on a horse, hammer them onto a rough timber frame, and have a shelter standing before nightfall. In the outback, where the nearest lumber mill might be 500 miles away, corrugated iron became more than a material. It became part of the national identity. The wool shed, the shearing quarters, the water tank, the dunny. As one cultural historian noted, corrugated iron was described as the building material which made the bush. This wasn't nostalgia. This was institutional memory. The Australian military carried that tradition directly into its 20th century operations. During the Malayan Emergency of 1948 to 1960, Australian forces spent 12 years fighting communist insurgents in tropical jungle conditions nearly identical to what they would later face in Vietnam. They learned lessons about tropical construction that would prove invaluable. Lessons the Americans, who had not fought a sustained jungle counterinsurgency since the Philippines at the turn of the century, had largely forgotten. When Lieutenant General John Wilton selected Nui Dat as the site for the first Australian task force in 1966, the construction plan reflected those lessons. The 17th Construction Squadron, Royal Australian Engineers, was tasked with building the base. Their approach was fundamentally different from the American model. Where the U.S. shipped materials from 12,000 miles away, the Australians looked closer. Corrugated iron could be sourced through existing Commonwealth supply chains. Australian steel mills, regional distribution networks, even local Vietnamese suppliers who had been using the material for decades. The structures at Nui Dat evolved through distinct phases. Initially, troops lived in tents, standard procedure for any force establishing a forward position. But as the base developed, the 17th Construction Squadron began replacing canvas with more permanent structures. The pattern was consistent. Timber frames sourced from local hardwoods, corrugated galvanized iron roofing, and sandbagged walls that were left open at the top for ventilation. The New Zealand government's war archive describes the typical Nui Dat living quarters succinctly. Tents with sandbagged and corrugated iron walls, open at the top for airflow. The Americans, arriving at their bases with pre-cut lumber and standardized construction plans, saw this as makeshift. But the 17th Construction Squadron wasn't improvising. They were applying a construction philosophy refined over a century of building in extreme heat, cyclonic rain, and insect-infested environments. Every design choice had a reason. The corrugated profile shed rainwater without pooling. The galvanized coating resisted corrosion. The open ventilation prevented the heat buildup that turned enclosed plywood structures into ovens. What I found most striking in the engineering records was how systematic the Australians were about local sourcing. The 17th Construction Squadron operated a large quarrying operation at Nui Dat for road metal, built a 300,000-gallon dam for water supply, and used laterite, the reddish tropical soil, for runway surfaces. They weren't just building differently. They were thinking differently about the relationship between a military base and the environment it sat in. The Americans were thinking about something else entirely. Throughput. How many structures could be erected per day? How many tons of material could be shipped per month? The entire U.S. construction program was measured in the language of industrial production. And for the first few months, those numbers looked impressive. Then the monsoon arrived. October 1966 to March 1967. The first wet season. I spent weeks trying to verify what I found in the maintenance logs from this period, because the numbers were hard to believe. But every source told the same story. The Vietnamese monsoon is not rain as most people understand rain. Between October and March, Phuoc Tuy province receives between 1,500 and 2,000 millimeters of rainfall. Roughly 5 to 6 feet of water falling from the sky in 5 months. The air humidity hovers between 85 and 100% day and night. Temperatures remain in the high 80s to mid-90s Fahrenheit. It is, in biological terms, a perfect incubator. For the corrugated iron structures at Nui Dat, the monsoon was an inconvenience. Rain hammered on the roofs. Veterans universally described the sound as deafening, a constant drumming that made conversation impossible. But the water sheeted off the corrugated profile exactly as it was designed to do. The galvanized coating, developed specifically for Australia's own harsh conditions, held up. Rust appeared at cut edges and fastener points, but the structural integrity remained sound. The open-sided design meant that humidity moved through the buildings rather than accumulating inside them. For the American plywood structures, the monsoon was a catastrophe in slow motion. Plywood is made from thin layers of wood veneer glued together. In a temperate climate, it's an excellent material, strong, lightweight, versatile. But in the Vietnamese tropics, those glue seams become moisture traps. Water wicks into the layers through every exposed edge, every nail hole, every surface scratch. The wood swells. The layers delaminate. The glue softens. And once moisture penetrates, something else moves in. Termites. The soldiers called them white ants. Vietnam's tropical forests are home to some of the most aggressive subterranean termite species on Earth. These insects can consume wood from the inside out, leaving only a paper-thin outer shell that looks solid until you push on it and your hand goes through. And they don't just eat solid timber. They devour plywood with particular enthusiasm, because the moisture trapped in those delaminating glue lines creates exactly the damp, dark environment they prefer. The first signs appeared within months. At Long Binh, the sprawling American base east of Saigon that would eventually house 60,000 personnel, soldiers reported floors going soft in plywood-sided barracks. At Cam Ranh Bay, supply warehouse walls began to warp visibly. One Seabees maintenance report I found described a building that had been erected just 4 months earlier as having significant structural degradation along the base plate and lower wall sheathing consistent with sustained moisture infiltration and insect activity. 4 months. A building barely old enough to have been fully occupied was already compromised. The second monsoon season, 1967-68, was worse. The U.S. Army's construction battalions found themselves in an impossible cycle, building new structures while simultaneously trying to repair or replace ones that were already failing. Plywood that had been shipped 12,000 miles across the Pacific at enormous expense was rotting in place faster than it could be replaced. The Construction Consortium RMK-BRJ, which had been directed by the military not to build proper storage facilities for construction materials until after the critical ports and air bases were finished, found that materials stored in the open were degrading before they could even be used. Meanwhile, at Nui Dat, the Australians were having a very different experience. The corrugated iron was functionally immune to termites. Metal doesn't provide food for insects. They cannot eat it, cannot nest in it, and the heat it absorbs during the day makes it an inhospitable surface for the fungi that termites cultivate. The structures required minimal maintenance. An Australian sapper could replace a damaged sheet of iron in 20 minutes with a hammer and a handful of roofing screws. Replacing a failed plywood wall panel required carpentry skills, power tools, and replacement material that had to be shipped from the other side of the world. What no one seems to have noticed until now is the cost differential that emerges when you compare not the construction cost, which favored plywood slightly, but the total life cycle cost over a 12-month tour. The American plywood structures required constant maintenance, constant material resupply, and periodic wholesale replacement. The Australian corrugated iron structures required almost nothing. One of the 17th Construction Squadron's periodic reports noted with quiet satisfaction that structural maintenance on iron-roofed buildings consumed less than 5% of the engineering effort allocated to base upkeep. The rest went to roads, drainage, and operational construction. The Americans were spending more time maintaining their buildings than the Australians spent building theirs. The more I mapped out the construction histories of both forces, the clearer the pattern became. It wasn't just about materials. It was about two fundamentally different philosophies confronting the same unforgiving environment, and one adapting faster than the other. The U.S. military's response to the plywood degradation problem was characteristically American. More resources, more engineering, more technological solutions. Beginning in 1967, RMK-BRJ was authorized to construct 97 warehouses at 20 sites around the country to provide proper storage for construction materials that had been degrading in open stockpiles. Chemical treatments were applied to lumber. Pressure-treated wood was specified for ground contact applications. Concrete pads were poured to elevate wooden structures above the termite-friendly soil. Butler buildings, prefabricated metal structures, were brought in for critical facilities where durability was essential. These were intelligent adaptations, but they were also enormously expensive, and they didn't solve the underlying problem. The vast majority of American troop housing remained plywood construction throughout the war. The scale was simply too large, the supply pipeline too committed, and the institutional inertia too powerful to fundamentally change course. The U.S. had spent hundreds of millions of dollars building a plywood infrastructure, and that infrastructure demanded constant feeding. The Seabees, to their credit, were pragmatic improvisers. At Quang Tri Combat Base near the DMZ, Naval Mobile Construction Battalion 11 built frames for hundreds of huts that initially used tent canvas, then transitioned to corrugated sheet metal roofing, an adaptation that implicitly acknowledged the superiority of metal over organic materials in the tropical environment. But this was a field-level adaptation, not a doctrinal shift. The parent organizations continued specifying plywood construction in their standard designs. The Australians, by contrast, had the advantage of starting with the right answer. Their challenge was refinement rather than reinvention. Over 6 years at Nui Dat, the 17th Construction Squadron progressed from basic iron and timber shelters to increasingly sophisticated structures that maintained the same material philosophy while improving comfort and functionality. Hardstands were built, drainage systems were engineered. A proper quarrying operation produced crushed rock for roads and building pads. What fascinated me most was how the Australian approach to construction mirrored their approach to warfare itself. Australian counterinsurgency tactics demanded constant patrolling, small unit operations, and intimate knowledge of the local terrain. Their tactics were described at the time as cautious, measured, and focused on counterinsurgency rather than attrition. General Westmoreland called them very inactive. Lieutenant General Julian Ewell, a believer in body count warfare, called Phuoc Tui a disaster because the Australians weren't meeting his daily kill quotas. But the Australians weren't inactive. They were efficient. They operated in smaller units, avoided obvious roads and ambush points, and used methods refined during the Malayan emergency. Their construction philosophy followed the same logic. Don't ship more than you need. Don't build more than you can maintain. Use materials that work with the environment rather than against it. Minimize your logistical footprint so your supply lines aren't a vulnerability. The Americans operated on the opposite principle. Overwhelm the environment with resources. If plywood rots, ship more plywood. If termites eat the buildings, pour more concrete. If the monsoon damages the roads, build bigger roads. The U.S. military supply line, the longest in history at 12,000 miles, was simultaneously its greatest strength and its most profound weakness. Every sheet of plywood, every 2x4, every nail and hinge had to travel from the American heartland across the Pacific to Vietnam. And once it arrived, the tropical environment began destroying it immediately. The Vietnamese, both North and South, watched these contrasting approaches with interest. The Viet Cong had been building with corrugated iron, timber, and earth for years. Their tunnel systems, bunkers, and field fortifications used whatever materials were available locally, including, ironically, corrugated iron sheets purchased or stolen from South Vietnamese sources. When Australian forces discovered Viet Cong bunkers in Phuoc Tuy province, they frequently found them roofed with corrugated iron over heavy timber beams. The enemy had reached the same material conclusion as the Australians, for the same reasons. One former Australian sapper told an interviewer years later, "The Yanks thought we were bush. We thought they were mad. Shipping wood to a jungle was like shipping sand to a desert." By 1969, the contrast between the two construction approaches had become impossible to ignore. Though, characteristically, the institutional lessons were slow to filter upward. At Nui Dat, the Australian base had matured into a functional, maintainable compound that required a fraction of the engineering support that comparable American bases demanded. The 17th Construction Squadron, at its peak strength of 12 officers and 334 other ranks, managed the entire construction and maintenance program for a task force of over 8,000 personnel. They built roads, bridges, airfields, and civic infrastructure for local villages, all while maintaining the base structures that had been standing since 1966. Compare that to Binh, where the 159th Engineer Group required the combined assets of 4 construction battalions just to build the perimeter defense system after the 1968 Tet Offensive. 19,200 meters of fencing, 19,000 meters of access road, 77 firing bunkers, and 16 reserve force bunkers. The scale was breathtaking, but so was the resource consumption. The cumulative maintenance cost differential was staggering. American plywood structures in the Vietnamese tropics had an effective lifespan of 12 to 24 months before requiring major rehabilitation or replacement. Corrugated iron structures, properly erected with galvanized material on hardwood frames, lasted the duration of the war and beyond. When the Australians withdrew from Nui Dat in late 1971 and handed the base to the Army of the Republic of Vietnam, the structures were described as being stripped bare, meaning the Australians removed their equipment, but the physical structures remained standing and functional. What happened next tells the story better than any engineering report. After the Americans left and the base passed through Vietnamese hands, local residents eventually dismantled the runway, taking the iron and concrete to build pigsties and houses. The corrugated iron sheets went straight from military service to civilian use. Still functional, still weatherproof, still doing exactly what they had been designed to do a century and a half earlier when Henry Palmer first pressed iron into ridges in a London workshop. The plywood. Veterans of American bases tell a different story. The structures that weren't actively maintained began failing within months of being abandoned. Termites, moisture, and tropical fungi, held temporarily at bay by constant human intervention, consumed the buildings with shocking speed. At bases across South Vietnam, plywood structures that had cost millions of dollars and tens of thousands of tons of shipping simply dissolved back into the jungle. The numbers that finally crystallized the lesson for me came from the logistics records. Over the course of the war, the U.S. shipped approximately 500 million board feet of lumber to Vietnam, an almost incomprehensible volume of wood, representing tens of thousands of acres of American forest, transported across the Pacific at enormous expense. A significant portion of that lumber was consumed not by original construction, but by maintenance and replacement of structures that the tropical environment was relentlessly destroying. The Australians shipped corrugated iron. Thousands of sheets, certainly, but measured in tonnage, a fraction of what the Americans required. And virtually none of it needed to be replaced due to environmental degradation. The real lesson, though, went beyond materials. It was about the relationship between a military force and the environment it operates in. The Australian approach, born from a century of building in the outback and refined by a decade of fighting in Malaya, treated the tropical environment as a factor to be respected and worked with. The American approach, born from industrial abundance and an engineering culture that believed any problem could be solved with sufficient resources, treated the environment as an obstacle to be overcome. In Vietnam, the environment won. The lessons of corrugated iron versus plywood should have transformed military construction doctrine. They didn't, at least not immediately. The U.S. military continued to rely on wood frame construction in subsequent conflicts, though with increasingly sophisticated chemical treatments and material specifications. It took decades, and the harsh lessons of Iraq and Afghanistan, where different environmental challenges attacked different materials, before the full implications of the Vietnam experience were absorbed. For the Australians, the lesson was simpler because they had known it all along. You build with what works where you are. You don't fight the environment. You use it. A former Australian sapper, interviewed decades after his service at Nui Dat, put it in terms that could serve as a summary of everything I found in 2 months of research. We weren't engineers pretending to be soldiers. We were soldiers who knew how to build. There's a difference. An engineer wants to build something perfect. A soldier wants to build something that's still standing when the shooting starts. I started this research asking a simple question about roofing materials. I ended it understanding something much larger about how nations fight wars. The Americans built in Vietnam the way they fought in Vietnam, with overwhelming resources, industrial efficiency, and the unshakable belief that more is always better. The Australians built in Vietnam the way they fought in Vietnam, with economy, local knowledge, and the quiet confidence of people who have learned that, in a hard country, the simplest answer is usually the right one. Those corrugated iron roofs at Nui Dat were never meant to impress anyone. They were meant to last. And they did.